Hey everyone, Juan here. Welcome to SQL Lingua Franca, the podcast about analytics that reveals what the documentation does not cover.
SQL Lingua Franca. Bio.
Today, we have my colleague Guillermo here. We're going to talk about how analytics engineer has evolved over the last 4 years, and even how the modern data stack is changing from DBT to SQLMesh, and even some of the cool things that Databricks is doing nowadays. Guillermo, would you like to introduce yourself?
Yes. Hi, my name is Guillermo Sanchez. I am originally from Madrid, Spain. Been living in the Netherlands for 5 years now. And I'm a big fan of many things. One of them, I guess, is the work that I do as a data professional, but also I do other things like climbing, and I love the outdoors as well. Yeah, and professionally, I've been working at Xebia Data for almost 4 years now. It's been a long time. I think, you and me joined together back in the day. I think in the last 4 years, I've seen a lot of different things in the data landscape. I've seen how the role of the analytics engineer has evolved quite a lot. I remember when we started with the team, we were probably like the only two analytics engineers in the Netherlands. I think now it has evolved so much, and it's something that is great to see. And I'm happy to be in the space. Now I think I am a principal for the team now for 2 years, and we're trying to grow obviously because there's a lot of demand for analytics engineering in the Netherlands.
I actually checked, and when I joined Xebia, there were 4 analytics engineers in the Netherlands, according to LinkedIn. And I'm sure that 2 of them used the title wrong. And now I checked recently, and it's a couple thousand. So in less than 4 years, a lot of crazy stuff has happened.
No, for sure. I remember we talked about this a couple of times when we started, but even when you created the first meetup of analytics engineering, most people that would attend the meetup, I think they were data analysts or data engineers, and they were slightly confused by the term analytics engineering. And I think now it's kind of well known. Like most people do know about this, and companies are starting to understand whether they should have analytics engineers or not. So it's definitely catching on.
It's been super interesting because back when we got hired, like the whole idea to start an analytics engineering team started in 2020. That's less than a year after somebody coined that term. So it really has felt, not to make our contributions to feel grandiose or say that we're like the most important people here, but because we were that early, it really felt that we have been like co-discovering and co-creating this field together. Just to give an example about the meetups, I remember back in 2020, I decided to create that group, and I'm like, this is going to be big. I really want to have the analytics engineering meetup. And if you look for it, meetup.com/analytics engineering meetup, you land in our page. Nowadays, I think there are like 7 groups, but ours is really definitely the one that doesn't have like the name of the city in the URL.
Yeah.
And that has been part of the vision of Xebia when we first started this, in thinking like this is going to be big. Let's start hiring people to do it, to develop this proposition.
Yeah, I remember. I think when you created that space, for sure in Europe, I would say, because actually the Netherlands was quite fast, I think, to catch on versus like other parts of Europe maybe. But for sure in Europe, nobody knew about analytics engineering. I think Xebia catch this pretty quick. Although still, I think when they hired us, they didn't really know what they were hiring for. I remember that, when we joined, we were like a bit different profiles, and we sort of converged together a little bit into what the team is today, right? Which is definitely a team of like skilled professionals in different ways. And I still think that there's a lot of sort of identity to find within analytics engineering. It's the thing is a bit complex because I think for every company it means a different thing. I think as consultants we are really sort of aware of this, where we would maybe land at a client and then tell them like, yeah, we do analytics engineering, and their interpretation of that can be completely different from another company as well. I think tech companies, they have like a more maybe native implementation of analytics engineering, like they understand the role, they are also better suited for the role, whereas big corporations do struggle a little bit to place these analytics engineers because they don't know whether they should be placed on tech teams or on business teams, right? Because they have this hard distinction usually. But yeah, it's I think even for them it's happening, right? So even for the big corporations.
It's interesting. I didn't think we were going to go this route, but yeah, you got me a bit nostalgic of this whole transition. Maybe, so we can all start this discussion. Can you start by telling us how you see analytics engineering nowadays and how we saw it 4 years ago?
Yeah.
Let's start with now.
Yeah, so I think nowadays, I think analytics engineering is sort of this fuzzy, like big scoped role that when it is placed onto a team, right? Analytics engineer is able to understand the whole flow of data within that context that he's given, right? So let's say analytics engineer lands in a specific domain in a company, right? He will understand how data is provided, right? So he will understand also the context of where the warehouse of that data of the data is being stored, like maybe this data lake or data warehouse, it doesn't matter. They will understand that context and they will be able to sort of model the data according to what the business needs, without really needing any other technical support from traditional data engineering, right? So they have this sort of technical autonomy, plus they are able to interact with the business in a quite native way, right? So I think this sort of hybrid of like a business savvy person, but also a technical savvy person is what makes analytics engineering today. And why do I say this is fuzzy? Is because for each company it will mean something different. And actually, analytics engineer is something that is independent of a tech stack. I think back in the day, going to the other question, 4 years ago, maybe analytics engineer was understood as something attached to the modern data stack, right? Basically, if you're using tools like Fivetran and dbt and a modern data warehouse, then you can have an analytics engineer, and the analytics engineer will be able to do the end-to-end flow from ingestion to modeling to serving reports to the business, for example. And I think today is something more, right? It doesn't matter what tech stack you're using, right? It could be older. It could just, it could be the modern data stack, but like nowadays there's a lot of tools that I don't think they go with that term anymore. And it doesn't matter because the analytics engineer will still fulfill this role, and I think it will still be needed by companies. I think that's my feeling right now, that it grew bigger than the modern data stack, let's say.
Yeah, if from my perspective, in the past, the definition was either fully technological, as in if you have something to do with dbt, you're allowed to call yourself analytics engineer, or the definition was interceptional. So it's either the stuff that data engineers or analysts are not able or don't want to do, that falls into your responsibility. But I think we really took into the challenge of going one step further and let's start defining ourselves regardless of the technology and regardless of what other roles do or don't. And that's when we started talking about is the modern data stack essential to be an analytics engineer? Can you just do it maybe in a old Oracle stack? And back then we didn't know, but today I'm 100% sure I'll say yes. The other thing is, what is the role of this person in the whole data democratization journey? Or what are the skills needed? One big point of discussion, because we did have a lot of meetings to define what exactly our role was.
Yeah.
We would constantly, I think between the two of us, for you, it's very important that an analytics engineer is an end-to-end endeavor that starts all the way from the way that data is ingested all the way to dashboarding. Well, for me, not necessarily, didn't have to be. And to be honest, like in those 4 years, I've been going back and forward. Sometimes I'm like, no, it really has to be end to end for it to work. And sometimes I'm like, no, because it's about the higher goal more than the specific responsibilities of the job.
Yeah, that's a very good point actually, and I do think that maybe I'm more flexible these days, like because I used to be a bit strict on this back in the day, particularly when we were hiring. I always wanted someone that could do something end to end, right? Like if you can prove that you can do ingestion, modeling, and visualization, then I know that you're the complete package. And I think for building sort of the base of the analytics engineering team within Xebia, that was the right call. But nowadays, I do believe that you can maybe be a bit more specialized within analytics engineering, and that's actually fine. But what I do expect from analytics engineers is that they do have some technical savviness, right? It doesn't have to be on everything within the process. But for example, you can be a DBT and LookML expert, and I would consider you a really good analytics engineer if that's sort of your calling, right? And you don't need to maybe know the intricacies of data ingestion. That's fine. But I guess technical savviness is usually something that is needed, because otherwise there's nothing that really differentiates you from like business users that know how to write SQL, right? You maybe are that one step further because you know Git, you know how to do basically you know how to do repositories in general, right? How to structure them, etc. Maybe you know a bit about deployment pipelines, and then that makes you different already. I do think though that something that I would expect from a good analytics engineer is to still understand what the end-to-end flow looks like, even if you are not an expert on every part of the flow, right? The same way that whether you had a specialty, Juan, or not, right? It didn't mean that you didn't understand the rest. You always understood the complete flow, even if you're more an expert on one part, and I'm for sure more an expert on another part, right? But we still converge in that we understand each other perfectly because we understand all the parts of the data landscape, sort of.
I agree. Yeah, we at first it felt more like a race. Like, oh, as soon as possible, I need to be an expert in orchestration and transformations and ingestions and Docker containers and everything. But now, I think I'm a bit more content with being at least mediocre in all of them, but being really good in a 3, 4, 5, a handful of them.
Yeah, it's only human also. Like, to be fair, I do think that also time taught me this as well, right? Because there's a point where you just realize that you cannot be an expert on everything out there, right? So choosing a specific path is also, I guess, good career advice for people out there going into analytics, right? Like, you don't have to be good at everything. It's good to know a lot about different things, but for sure, maybe become an expert in the particular ones that you're most interested on.
I think it's also a little bit of the zeitgeist of back then, because the modern data stack was becoming bigger, and the big promise is all of these tools are going to become trivially easy to do.
Yeah.
And I think the best example there is Fivetran. Like, of course, Fivetran has APIs and has like a more complex workflow if you need to, but for the beginners or for the companies that don't need it, it's just like, here is 3 clicks and data is already there. And so maybe it's a bit my immaturity as a professional back then, but I also genuinely thought that a lot of tools were going to strive to the whole, if you want it, it can be done in 3 clicks.
I do think, like for some specific things like data ingestion, I think Fivetran tried to solve like an obvious problem, right? Like this is not rocket science. We just want to copy data from A to B, right? If we just make standard connectors, everything will be good. But the truth is that I do think that there's some complexity, right? Even on that, even if Fivetran, I think, has tried to move towards buying other companies that have more specific connectors, I still land at a lot of clients where we do custom ingestions. So, yeah, maybe some of the problems are just hard to solve, right? But there's also a lot of legacy systems, I guess, that you still need to integrate with the data platform. So I think it really becomes hard to solve the analytics end-to-end problem like it's nothing, right? With a couple of clicks, as the promise was made to us. I think what I can see though is that when we go to a startup or a different type of company, I think most of the systems that they use are maybe like modern SaaS softwares, and then they have like a couple of integrations that they can use Fivetran for, and then it becomes way easier to do that part. Still, you need to model the business logic, right? But then there's standard packages for DBT, and then everything becomes again a little bit easier. So I guess it can be easier. You just need to have good source systems. Now that I think about it, right? Like if you have good source systems with standard data models, everything else becomes way easier.
Yeah, you're right. It depends a lot on, well, your organization.
Yeah.
If depending on what stack you're into, depending on some challenges like unregulated industries that use very common systems and don't require very massive data quality checks. I know that for some people, they must be thinking, especially those people that have stayed in those companies where, let's say, things are very easy to template. Like, oh, what's the big deal about this? I don't know why people complain. Well, and this is something we know because we're consultants. There are some companies where like the most trivial things are impossible because, or either human factors or other technological stuff. And you think, oh, it's super easy to solve. And they're like, oh, yeah, but this machine by regulations cannot have access to internet. So good luck with that. And you're like, ooh, okay.
Yeah, I think for sure. As consultants, we know that there's a lot of hard customers out there in this sense. I do think that even for the modern companies, as complexity grows, like even if you're using Salesforce, right? There's a lot of like pre-made modeling for Salesforce out there, right? There's a DBT package for that, etc. Or I don't know if it was a DBT package or a Fivetran package for DBT. Regardless. I think the problem is that, for example, at some point you want to customize certain things because your company does things in a certain way. And then you start adding custom dimensions, and then everything does tend to complexity at some point. Just with companies, this is something that happens, I think. But yeah, for sure, as consultants and having worked with really, really big companies with a lot of legacy systems, we've probably experienced like the biggest, more painful data sources that a human has ever seen. I've seen really difficult stuff.
Yeah, I don't wish it on everybody, but yes. I think working as a consultant, I know it's not for everybody, and some people will not like stick to this their whole lives. But I can definitely recommend it just to get to see all of the things that are there and you become really good much, much quicker than if you would be in the same stack.
Yeah, that's for sure. I do. This is not an advertisement. If you're looking for a job, you can come to Xebia if you want. But for sure, like if you become a consultant, you will grow way faster. This is just the reality because you are exposed to so many things. In such a short amount of time, so many different technologies, so many different problems that you need to solve. It's almost impossible, I think, to not become really good at your job while being in an environment like this.
Yeah. At the same time, you lose some of the ownership of the things that you're building.
Yeah.
So I guess for us, it's a bit harder to know like what's the impact that the things that we're building 5 years into the future. Just as an example.
Yeah, these days I would expect like in 5 years someone has come with a new technology and then there's a migration of the... No, I always feel like solutions on this era don't last very long because there's always like a better solution up ahead maybe. But for sure I think that's one of the things that maybe makes it a little bit harder to be a consultant, right? You don't get to always see the result of your efforts. If you keep in touch with the client, sometimes you do get the opportunity to talk to them, and you can ask them like, "Are you still using that tool that I implemented?" And they are maybe super happy with it, so makes you proud. But yeah, we cannot really get attached.
Yeah, exactly. So it's a different way of working.
Yeah,
Guillermo, one of the topics I wanted to talk to you about today is DBT, and more specifically, I know you have some theories over why, even though there are plenty of alternatives for, let's say, ingestion, for databases, for BI tools, why is it that DBT has been alone in that transformation space for that long?
Yeah, I think it's quite an interesting topic, right? It's like if you look at the modern set of tools for data, right? As you said, whereas data ingestion, you have a plethora of tools there. Most famously, maybe Fivetran, Airbyte, but also a lot others that are coming our way, right? Same with data warehousing. Most famous maybe Snowflake, BigQuery, Databricks. Of course, these are not only data warehouse; these are data platforms generally, but and same with dashboarding. You have a plethora of tools over there and tools for data science, etc. It really amazes me actually how DBT just took the market for data transformation tooling. I really think that there's not that many competitors out there, and I think when DBT came into place, I think they did something really interesting, which is that they not only created a tool, they created a concept. Because analytics engineering is actually something that they created, right? They created this concept of like, okay, you need this role within a company, and they sort of attached the name of analytics engineering to the tool of DBT. So now whenever you hire an analytics engineer, you actually, even though this is evolving now, we've talked about this, right? But back in the day, you hire an analytics engineer, you expect this person to work with DBT. So the more the role grows in the market, the more the tool grows as well. So it kind of binded itself to the role of analytics engineering, and because the role is also succeeding in the market, DBT is also succeeding as well, and vice versa, right? So I think it really took over smartly, right? And it also provided a lot of things that other tools didn't have at that time, right? So I think back in the day you used a lot of like maybe if you're kind of a database management type of person, right? You have some stored procedures to run queries against your database and create your views and your tables, etc. And I think this really, there was really no other better way, right? That you could use other tools like Informatica or specific tools for Snowflake like Matillion, but nothing I think had the sort of set of offering that DBT had. And that combined with the community aspect, I think it just took over the market. But it's really a phenomenon that, I don't know, I'm probably not the right person to study this. Like we need a sociologist or something to.
Yeah.
But it's really something incredible, I think.
I don't think necessarily they invented analytics engineering, but they were the first ones to operationalize it. As in, like, here is something that this person mentioned in a blog post. Our tool allows you to do it. It's drawing a parallel. Data mesh. Somebody's like, this is data mesh, but I think the thing that they didn't do is operationalize it. Because if there would have been like the official data mesh tool that allows you to do this, and this is the only way, as data mesh grew in popularity, that tool would have like also exploded. But I don't know, maybe I'm wrong, but I think that never happened. But DBT really managed to capture this transition that was happening in the transformations landscape, operationalize it perfectly. And because of the growth, yes, they were able to ride that wave like nobody else.
Yeah, I completely agree. I think operationalizing data mesh is way more complex, so that's maybe why they cannot do it. Although I think someone is trying, I think. But let's not go sideways. But for sure, just DBT definitely operationalized this role and this way of working, actually. Yeah? And I think one of the keys why they also seized the market a little bit is because they realized that, you know, by enabling a lot of people to use this tool, they could also like enable this self-serve analytics kind of mindset of like, you know, maybe you're not a super skilled person technically, but if you know how to write SQL and you can learn Git, you can contribute to the data modeling within your warehouse in a safe way, right? Using software engineering best principles, CI/CD, testing, etc., right? And I think that's a really powerful concept when you go into self-service analytics. Know that you can enable your users to do this sort of data warehouse modeling in a safe and in a safe way.
Yeah, I agree. the thing that I love is most of the tools I was used to working with, I'm talking about things like Tableau, they were very busy into making the speed of delivery as quick as possible. And like everybody can use this, it's fine. And I think they did it at the cost of things being maintainable or scalable. And I think DBT was like, without ever sacrificing these two things, how can we make all of these transformations accessible to people? And so, with that regards, maybe I'm too much of a fanboy or I don't know enough about the space, but I really like that idea. And I haven't really seen that too much in other tools of let's make something very accessible and very fast to write, but with the rail guards and never at the cost of scalability.
Yeah, for me, at least at the beginning, like DBT was really groundbreaking in these regards, right? Because otherwise you had to build your own sort of package, right, where you could manage maybe these things, right? So maybe I think in traditional projects that we had, we would build our own sort of tool for transformations on top of Spark, right, in PySpark, right, something like that. And basically we were trying to build a lot of the things that were already built into DBT, right? What I do see now, though, is that maybe in recent time, other tools have emerged to try to compete in this market. And maybe to name some, of course, Dataform of BigQuery of Google was there for a while, I think. But this is really bounded to BigQuery, so people don't find this really attractive, I guess, because you don't get the full support of the community that DBT has. And I think most recently a really interesting tool that clearly targets the DBT space, the transformations within the warehouse, is SQLMesh. And I do think actually that this is a really interesting thing, that the market, even though it's still of the incumbent, in this case DBT, that there's other tools out there trying to challenge DBT. So I really think that only tools can grow really if they are pushed not only by the request of the community, but also by the fact that some competitors are proposing something different. And this something different may spark curiosity, and maybe some people will go from DBT to SQLMesh. And yeah, this is actually something I think that makes the space more interesting.
The interesting thing about business is there are some companies that were the first ones, and they are always going to be the biggest just because they were the first ones. But we all have to remember Blockbuster, MySpace, well, I mean, depending on how old you are, Vimeo. No, sorry, I was thinking about the other one to make videos. Whatever. Let's take MySpace. They were undisputedly the biggest, and now like they're completely gone. What happens is other companies took all of the research and development cost that they had to like eat. They really had to see what works, what doesn't. Other companies, they can just copy what works and start from there.
Absolutely. And I think like in other parts of the space, you can see this quite easily, right? So I think the orchestration space, which is really crowded as well, right? With Airflow, Daxter, Prefect, etc. I think like Daxter and Prefect were born basically of, okay, we like Airflow, but here's a problem, here's another problem. We're going to build a tool basically that solves these types of problems, right? And for some reason, actually, this didn't happen in the transformation space for a while. But I think SQLMesh has tried to really do that in a bit of a different way, in its own way. For example, some of the things that they saw on DBT that maybe was lacking was like the ability to unit test. Of course, now you can unit test in DBT, but only since version 1.8, which is the latest one, right? You also have like the fact that DBT is not natively stateful. Actually, it has a manifest, which is a state, right? But these artifacts are not sort of built-in state. You still need to defer to this previous state. And I think it's really interesting that SQLMesh natively said, yeah, we are going to have a manifest. And they also introduced this sort of like more OPSI kind of way of doing data, where you can actually plan your deployments just like you do with Terraform. So you can do SQL mesh plan, and then it will check basically what are the assets that you have in your warehouse and see what is the difference with the current branch that you're developing right now. And that's mind-blowing. Like for people that like Terraform, this is like, oh, this is cool. However, it is more techy though, so some people will be like, oh, this is too much for me.
To be honest, I'm not familiar with SQLMesh, but those things are very interesting.
Yeah, I think they are interesting, and they're also different, and they try to highlight maybe things that DBT was lacking, right? The thing is that they come into a point where DBT has already, as you said, it's incumbent. It has won a lot of the market, and also I think their cloud offering, the DBT cloud offering, is improving a lot over the last year and a half or so. So it is going to be difficult to move some people away from that. I think maybe for companies that are interested in like the sort of open source version, they will maybe give SQLMesh a try and see how it compares with DBT Core. It's also quite nice actually because SQLMesh like natively parses your DBT project, so you can still actually run a DBT project within your SQLMesh. So I thought that was quite an interesting way of trying to get people to migrate to SQLMesh at some point. We support your DBT project, so you can come to us. But yeah, so I think some companies maybe that are running the open source version will maybe try it out. But for the cloud offering, of course, DBT is miles away, right? It's been there for a long time,
So maybe very specifically to you, what are the things that you miss in DBT?
Yeah, so I mean, it improves version by version, right? But I think maybe what I mentioned before, right? The state part, for example, in DBT generates these artifacts every run, and that is sort of the state of DBT. However, this is not, let's say, fully managed by DBT. For example, if you want to do a run comparing to a previous state, so that you only run, modified things, you still need to specify where this file sits, right? So, for example, if you want to do this type of run in a production setting, you need to always deploy this manifest to a bucket or something like that, where DBT can retrieve this. In DBT Cloud, this is managed actually, but not in DBT Core, right? DBT Cloud does store your artifacts, so obviously that's managed, but not in DBT Core.
Correct. It's always a good best practice to store your artifacts and to create some sort of logging.
Exactly.
But at the same time, I also think, why do I hear so many stories of people doing this themselves? Like, don't get me wrong, I've seen some people doing some brilliant stuff with the manifest and everything, but they have to build a custom solution towards it.
Yeah, particularly in DBT Core. It is true that in DBT Cloud, most of these things are solved. But for companies that, as I said, maybe don't want to go to the paid offering, for sure, maybe they don't want to have to build these solutions on top of DBT Core. Another thing that I think like about SQLMesh is like they try to build the solution like more Opsy style, as I mentioned before. And I think the fact
like
that
data ops?
Yeah, like data ops, exactly. So they had, for example, unit test from scratch, which is something that DBT only supported recently. And also like they do this sort of plan idea where basically you check the previous state and you can tell the developer, hey, this is what you're changing versus another environment. It can be production, acceptance, whatever environment you're referring to. And I think this is quite a powerful thing. However, it is, as I mentioned before, I think something that some developers will enjoy quite a lot. Maybe some more business-focused people that use DBT, they just don't care. So it really depends on what your user is, right? But yeah.
Yeah, because many of the things that you're mentioning are the types of things that once you have experienced them in another tool, like, for example, Terraform, you realize, whoa, this is a very nice to have. But if you haven't, you don't necessarily see why that's a problem.
Exactly. And I think this is, so what makes SQLMesh strong for sure is that it has seen basically what DBT has done and tried to improve it, maybe taking things from concepts from ops, right? Like this plan, for example. However, it is true that, as you said, like a lot of users of DBT, I think they won't experience this pain because they don't think this is a pain, right? Why do I need to plan against my warehouse? Why do I need to know exactly the changes? I already know the changes that I'm making. It won't make an impact, right? The truth, this is not a really resilient way of doing things. You should always check whether you have an impact or not, right? But yeah, main point is that I do think that for the more techie people, they will find these sort of features really interesting, right? However, I do feel like DBT is trying to cover this space a lot, and particularly in the cloud offering, they will try to move more towards offering these kinds of things. Also with the things that they did with data mesh, like model versioning, all this kind of stuff, right? Where you try to refer to a specific version of a model, right? So that you don't break contracts. Like they're trying to cover for sure these types of problems.
It's interesting because from a product building perspective, you have to make a difference between what they call delighters and dissatisfiers. The things that people really feel immediately as a pain, they're definitely dissatisfiers. And just building them is what makes it easier for somebody to transition from one product to the other. I don't think just building a product based on fully just delighters, you can convince the average person to fully transition into something.
Yeah, I completely agree. I think that's the thing is that for what some people is a pain, for other people is not, right? So you maybe build a tool for a more specific niche. And I think maybe this is what will happen in the space, right? That maybe it will break up a little bit and more technical people that, didn't enjoy DBT maybe because it was not like, I don't know, hardcore enough for them, right? It didn't have maybe like the guardrails that they were looking for, like these really particular ways of doing things and enforcement that you can do maybe with other tools. And these are the people that maybe, in the first place, they didn't want to use DBT and were still building their own custom solution so that they could do exactly what they wanted. So maybe for this specific niche, some other tools will arise, like SQLMesh. Maybe SQLMesh is the tool for them. But for sure, for other people, they just won't care.
There is another thing. I've been following the race between Tableau and Power BI for years. And what I notice is sometimes one of them comes with a revolutionary feature. And then so what? In 6 months or less, the other tool is going to copy it. It is only those points where you can really count this no, they diverge philosophically, as in we believe this is the best way of doing things versus that other way. That's where you really notice it. So maybe at the moment, the competition between DBT and data mesh is going to look a certain way. In 6 months, DBT is going to say, oh, this is cool, let's copy it back. But it is only until you start noticing their big differences more from a philosophical standpoint of how we believe transformation should happen, that we're not going to see a massive difference between products.
No, and I think actually that is what happens already. That's my belief, at least, where SQLMesh, I think they started to build things in a different way fundamentally. Like, for example, one of the fundamental things that they do is that they say, we don't have to do Jinja. You can do it, I think, but you don't have to do it because we parse, actually, for example, they parse the SQL, right? So they actually are using a package under the hood called SQL Glot that parses your SQL so that basically they understand every dialect. So this is a fundamental thing that DBT decided not to do, which is absolutely fine, but already sets them apart, I think, right? So I think they did take different stands, and I think it was the same actually for some of the orchestration that we discussed before, right? Where, Daxter or Prefect, they took different lines than Airflow because they wanted to be different, particularly from the beginning. I don't know how this is on the BI space. I mean, for what you tell me, like Power BI and Tableau maybe have some similarities and some things that they don't share. But maybe Looker is like a fundamentally different thing from Power BI or Tableau. So I think, maybe not to that extent, but I do think that SQLMesh would be like a Looker and dbt would be a Tableau. By the way, this is like, I hope I don't become some sort of meme because of this sentence that I just made. I'm not implying anything with this, but I mean, like in terms of difference, I think they are fundamentally different. Actually,
For sure, kind of very clear cut. Like some orchestrators care about tasks, and some orchestrators care about objects.
Yeah. Exactly.
That's interesting. Maybe transitioning from this, I'm curious, what do you foresee in the future of the data stack?
That's a good question. So, for example, if we look at more fundamentally big platforms like Databricks, I think Databricks, for example, is taking a particular stand where they try to do everything in one platform. I find this really interesting, actually, because I've been following Databricks for a while. I am actually a solutions architect champion for Databricks. And something that I always find interesting is that in every Databricks release, there's like 20 different things. Like, it's insane. They just grow in every direction. Like,
Yes.
the moment there was like something about generative AI, they were like, yeah, we have Mosaic AI, which basically can allow you to do like multi-agent deployments. I was like, wow, okay, these guys took like 3 months to build this, And then basically, there was this conversation about dbt cannot really do streaming. Okay, we will come up with this concept called delta live tables, and then you can do streaming with something as easy as dbt. I think, for example, Databricks is taking the data stack to this point where they are trying to offer something for everything. I'm not saying they are going to eat every partner up, because they still like their partners, I guess, but they do offer you a possibility within their stack for almost everything. So that's one way I see it evolving. Like even for ingestion, by the way, we were discussing ingestion before, right? Like Fivetran, Airbytes, etc. They actually recently released Lakeflow in Databricks, which is also an integration tool, right? So at this point, I'm like, do you want to do everything within the platform? So yeah, this is one direction that maybe we will see coming. I think other tools are happy with their place in the market, like Snowflake, for example, doesn't sort of eat up all the market that Databricks does. I feel like
they're also growing, I think.
They're also growing a lot, for sure, but I don't see them growing as much in the data science space, for example.
No.
Like, I think they never try to get that offering, right?
Oh, I don't mean I don't know if they're growing in terms of clients or not, but what I'm saying is their offerings are also growing, like you mentioned, in a lot of directions.
Yeah.
I think, and this is pure speculation, I think they're also trying to get some of the Databricks cake. I don't know how successfully. I'm not going to give my opinion at the moment. But yeah, with all of this movement of Snowflake apps and Snowpark that now you can run Python natively, and I do think they're looking at Databricks and saying, hey, this is something that we should also try to do ourselves.
Yeah.
It's funny because back when we started working, which I don't know exactly how long it was for you, but let's say roughly 10 years ago, the big paradigm was every tool has a very specialized place, and we modularize and microservices, and that was becoming the thing. And back then, Databricks was like, no, engineers love us, and Snowflake was like, oh, we make a tool that BI people are going to love. And now as time has passed, it feels that companies are growing more and more towards what we had before, which is the big platform that can do everything.
I completely agree with this, actually. And I think this is really interesting because, as you said, yes, Snowflake is also trying to do the same, right? Snowflake and Databricks are always trying to do this to each other, like eating from the same cake, of course. But I think you can also see this in, for example, Microsoft's offering, right? Like, you had all these services before in Microsoft, like Azure Data Factory, and then you had Power BI, and then most people were using Databricks for transformation in between, something like that. And then at some point they released Synapse.
And some people got suckered into Synapse.
Exactly. And then Synapse was offering like more, like it was like data warehousing, but also like some sort of a Spark clusters. And then at some point They do Microsoft Fabric. Actually, there was something in between, maybe, of signups and Fabric. No, I don't think so. I don't know. They release so many things. It's crazy. But now they're doing Fabric, right? And Fabric is also like a platform where they are trying to do multiple things, right? So they basically bundle a bunch of services into a platform, which is basically the same as Databricks and Snowflake are doing. But it's interesting because it's the first, I think, cloud provider that tries to go this route, whereas AWS and GCP are pretty much still, they have different services that you can bundle together yourself into a data platform, right? With GCP, you can do, for example, Dataflow, you can do BigQuery, etc.
Yeah, that's true. Never thought of it.
Exactly. And in AWS, it's the same. You can do EMR and you can do Redshift, And actually, these are different services that you bundle together. So it goes more in this direction of like, I choose my services and then I deploy them together versus the, you click this get license button and then you will get all of these services because this is my platform.
I don't know if you know this, but for very specifically for Fabric, you don't need to go to the Azure portal. It's like they have their own separate thing.
I think so, yeah.
At least in my head, it doesn't really feel like saying like, oh, this is like the new Azure thing.
Yeah, it's for sure a bit weird, but I do think, they're I think targeted to a different audience, let's say, right? So there will still be people that want to do deployments with Terraform, and those people will like cook something within Azure, like their own sort of deployments, and they will just have their ADF component and their whatever component, Databricks component, I don't know. However, like this, there's some people that just don't like to do this. They just maybe want to go to Microsoft Fabric and say like, yeah, I want to click this and then I want to click that, and this is
ClickOps.
more of like a ClickOps concept. So I guess that's why they made like a whole landing page for Microsoft Fabric, is for those people that don't want to do that. And maybe it is fine for them, actually. Like, it can be fine, I guess, for some people too. Yeah.
What do you think is going to be the fundamental differences between, okay, let me put it more concretely. You are an organization that is currently thinking between Fabric or Databricks. Maybe you don't know too much about Fabric because it's new and I know that your specialty is Databricks, but how would you convince them, or how would you how could you help them do that decision?
This is a really good question. Actually, we had this conversation with some engineers at Xebia the other day, like a couple of weeks ago. And I think sort of the conclusion of that was that if you are sort of like a techie company that wants to do deployments with Terraform, that wants to, deploy also using APIs of the services itself, right? So I want to deploy, I don't know, a Databricks job, and I use, the Databricks CLI to deploy this kind of thing, etc. Then maybe you want to use Databricks, because Databricks allows you to also that fine-grained control. Also, you can control costs a lot more because you know exactly what clusters you're using, the size, the auto-scaling. Like, you can even say, I want to use clusters with machines with, spot instances or a spot with fallback. Like, all these type of details you can actually configure in Databricks. If you use the Microsoft Fabric, right? I think there is a pay-as-you-go model for sure, but I think Fabric is sort of like a license-based kind of model, right? And then you pay for a specific capacity, and then maybe you deploy more in this ClickOpsy way. So it's definitely made, I think, for companies that don't have maybe this technical foundation, and they're looking for an easy-to-use, easy-to-deploy platform. So it's just like completely different clients. So I'd say if my client is techie and they want to go for like cost control and their own type of deployments, then for sure I would push them to something like Databricks or their own custom platform in the cloud. And then if they want something simpler, I think Fabric is the way to go, maybe.
I know Databricks has simplified this a lot throughout the years, but I remember when I first started using it, I would always tell the client, look, there are some type of engineers out there in the world that are constantly thinking like, what type of computer is this tool using to run my workflow? It's a bit too slow. Maybe you could add more of this or more of that to make it better. Those people do exist. Maybe like they're a bit more rare, but if you happen to have a lot of those in your team, or at least one, they're going to get a lot more juice from Databricks. But of course, I also am familiar that not everybody or the average person knows. For example, what is the effect of adding a bit more GPU to a cluster when you're doing data stuff?
Yeah. Now, for sure, I think like if you choose something like Databricks, particularly, I mean, Databricks these days also has serverless, and if you use serverless, you don't really care about anything
Yeah, okay.
that much at least. But back in the day when you didn't have when you didn't use serverless, you did need people that were able to monitor Spark applications, and actually that's hard, I would say.
Yeah.
I mean, it got better with time. I think Spark 3.0 made that better, but before Spark 3.0, it was a bit harder. And then you needed to know things like spill, what is, am I spilling to disk or not? Things like that. Or how many partitions do I have? Do I have data skewness in my partitions? Like all these things. Basically, you needed someone to look at the Spark UI and tell you these things. Like, you're actually having this problem. So therefore, you need to either tune your Spark application or just get a bigger cluster, more machines, more memory. And this type of person, for sure, is hard to find even today. I do feel like even for tools like Databricks, there's a lot that is moving towards serverless because there's less and less people that know about these things, right? So you just don't want the need to have someone with that type of expertise.
Yeah, and if you don't know how to fine tune a cluster properly, you're always better off running serverless than accidentally having somebody have like 8 clusters on all the time because
For sure. Serverless is like in that way safer, but for sure you can't optimize the cost of serverless, right? It is what it is.
And it's funny because going back to the satisfiers, back in the day I was more of a fan of Snowflake. Now I think it has changed in the last 3 years because I couldn't really reconcile with the fact that Databricks or Spark was so difficult to admin, to be sure what's happening, to secure, to like sometimes it would say some workarounds like, oh, you need to mount the data here, but then like, okay, and where can I see which clusters have this data mounted without having to open all of them? I thought admin was a nightmare. And then on top of that, also, I know that for a lot of people, setting up clusters for them and for their workflows and thinking about that, I didn't think was scalable. And I have to say, they really stepped up. And now with Unity Catalog, it's still not perfect. But now those two big pains that I used to have with Databricks back in 2017 when they appear in my radar, I think they're slowly disappearing.
Yeah, I was just going to say that Unity Catalog completely changed the game in that regard because, the mounting thing, that was not nice. I mean, I think most people can agree that it's way easier to just have a table that you know that you can access. You don't really care about like mounting some sort of like directory in a bucket somewhere, right? You also don't want that technical complexity, right? You want maybe that. I mean, for sure, the person that actually the engineer that sets up Unity Catalog, they do have to go through these pains, right? They do have to go through the pains of setting it up, right?
Yeah.
There's something in the background, some storage that actually belongs to you. It's in your cloud account, right? And then you need to, do the connectivity, make sure, VPCs are in line, and whatever service account or depending on where you are, whatever you're using, basically to authenticate, that you're doing this right. So all this setup in the background. For sure, it's still hard to this day, but for the data professional, right, that is actually using this data, it's way easier. Like now you have a table, and you don't really need to care that much about this table. And to be fair, though, still it's probably easier to maintain tables in Snowflake than in Databricks, just because I think Delta table being an open table format, it does have some complexity to it, right? Like still they are recommending you maybe to optimize the table every now and then. You can use things like auto-optimize and these things, but still it feels a little bit more, it needs configuration and input from my sides to be optimized, this table, for my use case. Whereas I feel like in Snowflake, maybe that was always taken care of, and that's quite nice, right? But yeah, definitely they're sort of almost feature pairing in this sense, right? Whereas in the past, accessing data in Databricks was a bit of a pain.
No. But I also see it as unavoidable. Like every tool needs at least one admin, which is a person that knows a lot of like the hidden complexities and is able to enable lots of people to work with the tool, at least in a more superficial level. The question is, how many people can the average admin enable? If you're talking like for every 10 people, one of them needs to be an admin, it's very different than, oh, you just need to hire a consultant once to get this done, and then 1,000 people can work with this for like years and maybe call that person every 6 months to do a small audit.
Yeah, I definitely agree with that. I think with a good setup, maybe you can, maybe sort of limit the amount of people that need to be admin, sort of like what we call the platform team, actually.
Yeah.
Right. Maybe you provide like a good Terraform setup, and then some sort of like abstraction where if people need access to a specific thing or need to deploy something, they just make a small contribution to our repository in a config file, and then you get that deployment done. Like these kinds of things that I think at Xebia we do a lot. They sort of solve the admin problem a little bit, so that you don't need that many admins. But yeah, it's always nice actually to have this sort of platform team or admins team, right? That they actually double check that you're not doing something crazy. Because we go to a lot of companies actually, and then we find that they have like these crazy cloud costs, right? Or something like that, or Databricks cost, or Snowflake cost. And the reason for that is that maybe they got rights to deploy the biggest cluster in the planet, and that is fine if you know what you're doing, and maybe there's a purpose why you're doing that.
No.
But normally there's not. There's just like, I just want a big cluster. I didn't know it cost so much.
Yes.
So it's nice actually to have these people safeguarding that this doesn't happen.
Most people are not aware of, one, what is the amount of value that you're getting, like let's say in terms of strategic value, or in terms of like automating processes so you don't need manual intervention. That has definitely a value, which is like the revenue that you're getting from using this solution. But then comparing that with the cost, I don't think a lot of people do that exercise. But Guillermo, we're almost running out of time. So I think a perfect bridge is to ask you, with all of your expertise, let's say that you're an organization that has a massive, let's say, Databricks bill. What steps would you recommend the listeners to do to get it under control?
Yeah, so this question is difficult to answer, but for sure the first thing I try to look at is at the workspace level, who's spending the most, right? And I think that's, let's say if you have a workspace per team, you can focus on a specific team that has the biggest cost. And then for this team, I'll take a look at the infrastructure that they are running. What type of clusters are they running? Are they using like serverless warehouses? Are they using like a specific spot warehouse? Are they using all-purpose clusters? Are they using job clusters? These kind of things, to sort of understand what they are using. Also look at what products they are using, if they are using Lakeflow or if they are using Delta Live tables, right? And then get an idea of why they use these things and whether they need some specific things or not, right, for their use cases. Then if there's specific cases that use a specific cluster or a specific cluster that is really, really big, then they need to justify why they are doing this. And there's really easy way to do this. You profile the application and you see whether actually the resources are being used or not, and whether they are necessary or not. And sometimes, if the resources are used, this is because the application is written poorly. And then this is the worst thing that can happen, because that means that you need to actually rewrite code to save costs. And this is probably the thing that people don't want, right? That there's a custom Spark application that spends a lot of money just because it was poorly written. This requires basically just refactoring your application. And hopefully this is like the last thing that you need to do. And just by maybe making things a bit smaller and making sure that some products are not used that shouldn't be used, you can already cut the cost quite a lot.
So best case scenario, it's a matter of just turning it off and we can go home early.
Yeah.
But it can also be a matter of you learning how to properly optimize Spark, which
Indeed.
It's an art form in itself.
Indeed. Hopefully you don't have to do that. But for some really complex cases, that needs to happen. Yeah.
Perfect. Thank you so much, Guillermo. It was a really fun episode.
Thank you, Juan. I really enjoyed it as well.